When addressing safe work practices on poles and maintenance and inspection programs for power company equipment, several key resources provide guidance. These resources cover various aspects from electrical safety in the workplace to specific recommendations for maintaining electrical power poles. Regarding safe work practices on poles, NFPA 70. The standard for electrical safety in the workplace is a primary reference. Article 110 within NFPA 70. Addresses work on or near electrical lines and equipment. Annex G of NFPA 70. Specifically focuses on work on or near overhead lines, offering detailed recommendations. OSHA 1926 Subpart V, which pertains to electrical standards, also provides relevant information. Specifically, Section 1926.950 addresses overhead lines and the safety precautions necessary when working around them. These regulations and standards aim to protect workers from electrical hazards and other risks associated with working on or near poles. Concerning maintenance and inspection programs for power company equipment, NFPA 70. The recommended practice for electrical equipment maintenance offers guidance. Chapter 5 of NFPA 70. is dedicated to inspection and testing procedures outlining how to properly maintain electrical equipment to ensure its safety and reliability. IEEE Standard 1319 serves as a guide for the maintenance and operation of electrical power poles. This standard provides detailed recommendations on how to maintain poles to prevent failures and ensure their continued safe operation. The National Electrical Safety Code, or NESC, also includes rules related to the safety of power lines and equipment. Rule 250 of the NESC addresses clearances of lines from other objects, ensuring that power lines are properly separated from buildings, trees, and other structures to prevent accidents. Rule 252 of the NESC covers the inspection of plant and equipment, requiring regular inspections to identify and address any potential safety issues. In addition to these codes and standards, several organizations offer additional resources and information. The Electric Power Research Institute (EPRI) conducts research and provides technical expertise on a wide range of topics related to electric power, including the maintenance and safety of power delivery systems. The National Rural Electric Cooperative Association (NRECA) represents rural electric cooperatives across the country and provides resources and training on safety and operational issues. The American Public Power Association (APA) represents public power utilities and offers resources on a variety of topics, including safety, reliability, and sustainability. It is important to consult the most recent editions of these codes and standards, as they are regularly updated to reflect new technologies, best practices, and lessons learned from past incidents. Consulting these resources and adhering to the recommendations can help ensure the safety of workers and the reliability of electrical power systems. Understanding and implementing these safe work practices, maintenance procedures, and inspection programs are essential for preventing accidents and ensuring the long-term safety and reliability of electrical infrastructure. For safe work practices on poles, consider the following key areas. Firstly, hazard assessment. Secondly, proper training. Thirdly, use of personal protective equipment, or PPE. Fourthly, adherence to minimum approach distances. Fifthly, pole inspection. Sixthly, proper climbing techniques and equipment. Seventhly, communication and coordination. Eighthly, emergency procedures. Firstly, a thorough hazard assessment should be conducted before starting any work on or near poles. This assessment should identify potential hazards such as energized lines, deteriorated poles, environmental conditions, and other risks. Secondly, all workers involved in pole work should receive comprehensive training on safe work practices, electrical hazards, and the proper use of equipment. This training should be regularly updated to reflect changes in technology and best practices. Thirdly, appropriate personal protective equipment, including hard hats, safety glasses, gloves, and arc-rated clothing, should be worn at all times when working on or near poles. Fourthly, minimum approach distances from energized lines should be strictly adhered to. These distances vary depending on the voltage of the line and are designed to prevent accidental contact with energized conductors. Fifthly, Poles should be inspected regularly for signs of deterioration, such as cracks, decay, or insect damage. Any poles found to be unsafe should be repaired or replaced before any work is performed on them. Sixthly, workers should use proper climbing techniques and equipment, such as climbing belts and lanyards, to prevent falls. Climbing equipment should be inspected regularly to ensure that it is in good working condition. Seventhly, clear communication and coordination are essential when working on or near poles. Workers should communicate with each other and with supervisors to ensure that everyone is aware of the tasks being performed and any potential hazards. Eighthly, emergency procedures should be in place to address accidents or other unexpected events. Workers should be trained on these procedures and should know how to respond in an emergency situation. For maintenance and inspection programs for power company equipment, consider these aspects. Firstly, regular inspections. Secondly, preventative maintenance. Thirdly, equipment testing. Fourthly, record keeping. Fifthly, training. Sixthly, adherence to standards. Seventhly, corrective actions. Eighthly, documentation of procedures. Firstly, regular inspections of all power company equipment, including poles, lines, transformers, and substations, should be conducted to identify any potential problems. These inspections should be performed by qualified personnel and should be documented in detail. Secondly, preventative maintenance should be performed on a regular basis to prevent equipment failures and extend the lifespan of equipment. This may include tasks such as tightening connections, lubricating moving parts, and replacing worn components. Thirdly, equipment testing should be conducted to verify that equipment is functioning properly and meets all applicable standards. This may include tests such as insulation resistance tests, transformer turns ratio tests, and circuit breaker timing tests. Fourthly, detailed records should be kept of all inspections, maintenance, and testing activities. These records should include the date of the activity, the name of the person who performed the activity, and any findings or recommendations. Fifthly, all personnel involved in maintenance and inspection activities should receive comprehensive training on the proper procedures and techniques. This training should be regularly updated to reflect changes in technology and best practices. Sixthly, all maintenance and inspection activities should be performed in accordance with applicable standards and regulations, such as those issued by NFPA, IEEE, and OSHA. Seventhly, corrective actions should be taken promptly to address any problems identified during inspections or testing. These actions may include repairing or replacing damaged equipment, adjusting settings, or implementing new procedures. Eighthly, all maintenance and inspection procedures should be documented in detail to ensure consistency and accuracy. This documentation should include step-by-step instructions, checklists, and any other information necessary to perform the procedures correctly. By implementing these safe work practices and maintenance and inspection programs, power companies can significantly reduce the risk of accidents and equipment failures, ensuring the safety of workers and the reliability of electrical power systems. In addition to the resources already mentioned, it's also beneficial to consider information from the Occupational Safety and Health Administration, or OSHA. OSHA provides specific guidelines and regulations for working around electrical hazards, which are crucial for ensuring worker safety. OSHA standards, particularly those under 29 Code of Federal Regulations, or CFR 1910.269 for electric power generation, transmission, and distribution, and 29 CFR 1926 Subpart V for construction, offer detailed requirements for safety-related work practices. These include proper grounding techniques, use of protective equipment, and safe approach distances from energized conductors. Understanding and complying with these OSHA regulations is vital for any contractor or power company involved in working on or near electrical poles. Furthermore, the National Institute for Occupational Safety and Health, or NIOSH, provides research and recommendations for preventing work-related injuries and illnesses. NIOSH publications and alerts can offer valuable insights into specific hazards associated with pole work and best practices for mitigating these risks. For example, NIOSH may have reports on the causes of pole failures or recommendations for improving climbing safety. Consulting the OSHA sources can help identify emerging hazards and implement proactive safety measures. When evaluating the condition of cedar poles, it's important to consider factors such as age, environmental conditions, and previous maintenance. Cedar poles are naturally resistant to decay, but they can still be susceptible to damage from insects, moisture, and mechanical stress. Regular inspections should focus on identifying signs of deterioration such as cracks, splits, decay, and insect infestation. These inspections should be performed by qualified personnel who are trained to recognize the signs of pole damage. In addition to visual inspections, pole testing methods can be used to assess the internal condition of poles. These methods may include sounding the pole with a hammer to detect hollow areas or using specialized equipment to measure the pole's strength and stiffness. The results of these tests can help determine whether a pole needs to be repaired or replaced. When repairing damaged poles, it's important to use appropriate materials and techniques. Repairs should be performed by qualified personnel who are familiar with industry standards and best practices. Common repair methods include reinforcing the pole with steel or fiberglass wraps, injecting preservatives to prevent further decay, and replacing damaged sections of the pole. It's also important to consider the environmental impact of pole maintenance activities. Preservatives used to treat poles can be harmful to the environment, so it's important to use environmentally friendly alternatives whenever possible. Disposal of old poles should also be done in a responsible manner to prevent pollution. By following these guidelines and consulting with industry experts, power companies and contractors can ensure the safety and reliability of electrical poles and protect workers from the hazards associated with pole work. The key takeaway is that a comprehensive approach to pole safety involves not only adhering to codes and standards, but also implementing proactive measures to identify and mitigate potential hazards. This includes regular inspections, proper maintenance, and ongoing training for workers. Remember that the information provided here is intended for general guidance only and should not be considered a substitute for professional advice. Always consult with qualified experts and refer to the latest editions of relevant codes and standards before performing any work on or new electrical poles. Finally, consider local and regional regulations that may apply to pole safety and maintenance. These regulations may vary depending on the location and the type of utility involved. Compliance with all applicable regulations is essential for ensuring the safety of workers and the public. By staying informed and proactive, power companies and contractors can maintain a safe and reliable electrical infrastructure.